Hello and welcome. One of the most important concepts in computer graphics is a double buffered display system. That is a set of two images where one is being presented to the screen, and then at the same time the second image is being drawn to by the program, and then every frame those are flipped around, updating the screen without any visual anomalies. The analogy of this, or this fits into Vulkan's kind of concept of a swap chain. So a swap chain is a set of images. It doesn't have to be just one or two. It can be heaps, and a procedure for refreshing and updating, selecting one image to draw to, selecting one image to present to the screen. So the next step in our creation of this app is to set up a swap chain. So there's a bunch of things involved in this. First of all, we want to specify that we are requiring the swap chain. So we set this into a list called device extensions. It's very similar to what we did above with validation layers, requesting those. And we'll run some functions to test that our device can support a swap chain, which it should, because our device is only really suitable if it supports a present capability, which means it should have a swap chain. I don't know how a device can present without a swap chain. And then we are going to select or specify some options in our swap chain. So if we have a look down below, swap chain has some basic details. Basically, well, I've written it here in the comments, right? The number of images which the swap chain supports, with a minimum and maximum image count, and width and height. The pixel format. So, for example, in this one, we're going to use 32 bits with 8 bits for each of red, green, blue, and alpha. And the presentation mode. Okay, so we're going to check that our device supports a swap chain, then we're going to select appropriate settings for our swap chain, and then we're going to configure our swap chain, and then there are some extra little bits involved. So let's go down to the... Here we are. The device selection. So the first step is we want to change our isDeviceSuitable function. So we get our QFamilies, and again, if QFamilies is complete, then that's good. And then we also have this variable, is the swap chain adequate? So what we do is we check if our device supports the swap chain extension, which is running in this function up above. So the first thing we do is we populate a list of all extensions which our device supports. So this is a familiar procedure. We run it first with null pointer for the device, the queue that we're filling, and just a reference to the count, and then it fills that up. And then we run it again with a reference to the queue that we're filling, and it fills that up with a list of all the names of the extensions which the device supports. Then we take our device extensions which we are requesting, and we turn that into a set. And there's no particular reason to do this compared to, say, another loop or something. But this is how I'm going with it. So we loop through each of our available extensions, and then we erase them one by one from our set of required extensions that we're requesting. The way the set structure works, if we try to erase something which does not exist within our set, then it doesn't throw an exception or anything, it just doesn't do anything. So if we go through and each of our requested extensions have been matched by the device, well, then we will have an empty set. So this return will be true, otherwise it will be false. Okay, so if our extensions are supported, in other words, if we're supporting the swap chain, then we need to check explicitly what sort of swap chain can be supported. For instance, my device might be able to store images in a bunch of different formats, but I just want to check that there's some format, or I want to know which set of formats does my device support. So that's what I'm doing down here in query swapchain support, which I've created down here. Okay, so again, we create a one of these structs, which I defined up above, which had the set of capabilities we support and the types of formats and present modes. And then we just check through that. Okay, so right, so we go into the details capabilities, send a reference to that, and populate it with the get device surface capabilities function. Then we do the, well, this code kind of speaks for itself. So we run this first to get the number of formats that we support. Then we resize our vector so that it has, so we're not doing like a bunch of nested copy constructors and pushbacks. Then we pass that vector in and populate it with the older set of surface formats which the device supports. And then similarly, again, we run this function first to populate the number of present modes, and then we populate this with details present modes. We populate it with all of the present modes which the device supports. So this is not doing any selection, it's just getting the full set of everything which the swap chain could possibly support, or the device could possibly support. Okay. Okay, so we go back up here, and then the test to see whether we can even make a swap chain is we don't want, we want to have at least one format type and at least one present mode available. Okay, so now what we need to do is, let's go down to the logical device creation, and we need to pass in basically to tell Vulkan that we are supporting Swapchain when we create our device. So we go, yep, send that in. Good. Okay. So then the rest of this is we need to select the image size that we want to present on the screen, select the image format, and the present mode that we want to do. And then we want to actually create our swap chain. So we have a bunch of these. Choose extent, choose surface format, choose present mode. Okay, so most of the time, because we've created a GLFW window, it should pretty much just support, it should be able to support that specific width and height. However, if it lets us do something different, then it will send back this sentinel value, the maximum 32-bit unsigned integer. In that case, we'll just pass back the current extent that our capabilities have, and we'll handle that separately. But otherwise, let's just go ahead and request our screen width and screen height, which in this case is 800 by 600. So what we do is we set this up, and then we clamp it with a min-max, or a max-min, based on the minimum image extent width or height, for example, which the video card will support. Cool. This is a fun video. I'm speaking very eloquently today, but bear with me. Or just go into GitHub and grab the code. That works as well. So Right, so we set that up and we return that extent. Think of an extent as just a structure which has a width and a height. It's really all it is. Okay, then surface format. So what are we doing? Well, we look through our set of formats which are supported, and what we want to do is we want to go RGBA in sRGB, standard RGB, and in this case we'll use nonlinear color space. It just looks a bit better. And if that is available, then we return that. And if we don't find that in our support, then we just return something, right? Doesn't really matter. And then present mode. So we have a look through these. Now, mailbox is probably the preferred present mode. So the way mailbox works is we have a set of images, and then when that set of images is full, then old images are overwritten automatically without doing anything weird. We return that. But if that's not available, then FIFO, first in, first out, is, I believe, I think it's the only mode which is really guaranteed to be available for a swap chain. So we can just return that. Okay. So now we need to create the swap chain. So we get the support which is available. And by the way, the way this fits into everything is in our init vulkan, we do all of this work as before, and then at the end we create the swap chain. And we've got some other member variables here. We want to grab the swap chain. We want to, after the swap chain has been created, we want to grab handles to all of the images in the swap chain. We also want to store what kind of image format and extent, so width and height, we are going to be using, because that will be useful in other subsequent stuff that we do with the app. Okay, cool. Create swap chain. So we query the support based on our physical device, and then we just go through all of these functions. We choose extent, format, and present mode, and then we proceed. So we want to request an image count, and we want to use as few as possible. So the minimum image count which is supported, but then just add one so that we don't have our CPU like spinning empty cycles waiting for an image to become available for graphics rendering. So we just go one more than the minimum, and we also check if that, we clamp it by the maximum basically. Then we create a structure for the create info of the swap chain. Yeah, this code should be pretty self-explanatory. So we pass through the information that we queried earlier. Image array layers. For example, if we're doing medical imaging, there would be a series of layers for each image, but we're just presenting 2D images to the screen, so we'll just go one layer. Image usage. So we are going to be drawing these images to the screen, so we're using them as color attachment. For example, if we were rendering images but rendering them off screen to be used for something, then we would pass through image usage transfer, for instance. So it's saying, okay, we're storing it. What we want to do with it is we want to transfer the memory somewhere else. But in this case, we're color attachment. Right. So then we have this thing called image sharing mode. And what that comes down to is, in our graphics card, are we using the same queue family for both presenting and graphics work? Which is, I believe that's the normal case for most cards. So what we do is we grab our queue families, and then we check if the queue and graphics are equal to each other. are not equal to each other. And if they're not equal to each other, then we set the image sharing mode as concurrent, and that's just telling the swap chain that different queues will be accessing the swap chain kind of non-exclusively. So be prepared for that and do a bit more work to synchronize that sort of stuff. Then we need to pass in the queues which are working on it. But if those families are both the same, then really we've just got one queue which is working exclusively with the swap chain, so there's no concurrency issues. So we set that as exclusive mode, and then we can say just set that to 0 and null pointer, because the default in exclusive is less complicated. Okay, so then we've got some other fun stuff. Pre-transform. We might want to, off the bat, by default, do some sort of transformation to the images. In this case, we don't. So we set that to the current transform, which is the identity transform. For swap chain capabilities, composite alpha, we do not want to use any alpha blending at this point, so we'll set that to opaque. That's no alpha blending. Present mode, we pass that through. Clipped, so if we've got a window and then another window, for instance, hovers over it, well then those pixels, we don't really care about them. That's called clipping, and we want to set that to true. And then if the swap chain is rebuilt, well then it's a lot of work to rebuild a swap chain. We could inherit from an old swap chain, but we're not worrying about that yet. Rebuilding is cases like if I minimize a window or resize a window, the swap chain has to be rebuilt. But we won't worry about that just yet. And then we go and create the swap chain. And this is pretty standard. Okay, so then the next point is we need to get some information about the swap chain. So we call this get images. And again, because standard thing, we call it once to get the number of images that are in the swap chain. Then we resize our vector, and then we call it again to populate the vector with the set of swap chain images. And then we just query the format and extent and store those in member variables. Of course, this has to be cleaned up at the end, but the only thing which needs to be destroyed is the swap chain, because the images are references to images which exist inside the swap chain, so those do not need to be explicitly destroyed. Cool, so hopefully that's covered everything. I know we're getting up there in terms of time. It is a bit rambly, but there we go. So we run it, and it hasn't thrown any errors. And I think before we were using about 46 megabytes or 43 megabytes of memory. Now we're using 54. So that's our progress metric at this point. If we're using more memory, something has been created. Cool. Yeah, anyway, that will be it for now. Have fun. Code is linked in the description. And yeah, that's it. Bye.